Modifying structures. We are surrounded by modern technology that is entirely dependent on medical advancement, and we have a lot of baggage in our lives. A plane flying in vehicle, mobile mode, shifting car without an operator, and antenna that provides the majority of vehicle mobile sign electricity are all examples of manipulated structures. The antenna control system consists of electronic and mechanical components with control algorithm. The smallest possible pointing error, high speed, low power system are the prime requirement of the system.
السلام عليكم ورحمة الله وبركاته. I am Saleh Saeed Baisha with ID FB19068. Today I'll present what is the software we use and why we use this software. Our team utilizes the Simulink software from MATLAB for this project since it has a genetic algorithm toolbox that makes it easy to create mathematical models of generator extensions system. The most common way for determining the model is to use mathematical model that entails drawing a block diagram and performing a Laplace transform, depending on the parameter value necessary to acquire the design requirement. Now we will move to the next presenter for the next part.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Ahmad Hassan Al Gunfidin, FB19102, and today I'm going to talk about the block diagram of the system for controlling the position of the antenna. As you can see in the picture in the block, that the system for regulating the telescope antenna position consists of 2 point meters, one at the input and the other at the output, a power amplifier and preamplifier, a load and a motor. As previously indicated, the multimeter converts the input angular rotation into a voltage to start the operation. Similarly, the voltmeter in the output region converts the rotation angle to a voltage, which is given back to the input through feedback. As a result of a gain and signal, the difference between input and output voltage rose that the motor receives no voltage and will not start as soon as mistake or error it occur, and hence zero.
Assalamualaikum. My name is Norus Maiza binti Rohaiza. So here I'm going to explain about the design for the project, which here we have the block diagram. As you can see, the parts are located according to their position. We have here potentiometer, preamplifier, power amplifier, motor and load, gears, and also another potentiometer. So next up is the schematic diagram. It is more detailed figure from to differentiate between the block diagram. So as it same goes as the block diagram, which we have here also the potentiometer, the preamplifier, power amplifier, the motor, the gears, and also another potentiometer here, and then straight away to the azimuth angle output. As the design was made, there are two types of controller system that are made for the project, which are the open loop and also the closed loop. So here is the open loop system for the antenna. We have here the start, the power amplifier, motor and load, and also gear. So here is the result for the open loop system. And another one is the closed loop system, which is more complex compared to open loop. All the values are input according to the calculation that we have made manually. So this is the result for the closed loop system. So for the elaboration on this graph, I will be on these two graphs, which is closed and open loop system, will be explained by Nik Nur Fatiha.
Okay. My name is. I will continue my part, which is result. Okay. The design of open loop and closed loop antenna system, as well as the determination of amplifier gain K, are both process carried out in order to stability the system by meeting a specific requirement. Then the only some block required to complete the construction of open loop antenna system are a power amplifier, motor, load and gear. Then the block reduction method must be used to calculate the transfer function of the open loop antenna system, which denoted by the symbol GS. Okay, then because of the output value is not looked back of verification purpose in this design, the gain K is not required to be implemented. The last one, as a result, the potentiometer is not pre-amplifier are required. As you can see, this is a two-bulb system in simulate using the building block in simulate. As you can see, the picture. Then the graph of open loop system based on simulate block diagram. As you can see, this is output data from calculation in open loop system. Okay, then moving on. Okay, this is a closed loop system. Okay, this model will include the modification of the output response in order to achieve the desired response. Next, the diagram a complete version of one of the system building block. After obtain the transfer function without counting feedback, donate by kg. The next phase in to obtain the final transfer function with feedback donate by t. Okay, the last one. This will finish the transfer function hash. The feedback variable has been assigned a value of 0.318. As you can see at the picture, this is also simulate block, building block. Okay, moving on. Graph of antenna closed loop system based on simulate block diagram. As you can see, this is output data from calculation in closed loop system. Okay, I think that's all from me. Thank you.
So here we have the coding that have been simulated in the MATLAB for the open loop step response and also closed loop step response. So here are the coding that have been inserted. The first one we will have the open loop, and second one we have the closed loop. So based on the graph itself, to conclude the design of a state feedback controller for an antenna azimuth position that was shown in the simulation as the response is acceptable and desired because it has zero steady state error and also have a small value of settling time and overshoot. Compared the existed system step response with PID controller which has a short rise time and also a quick response. I think that's all from me. Thank you.